Hi, I'm Ken with BC Wood. Thank you for joining this recorded webinar from Wood Talks at the Global Buyers Mission. For learning accreditations, complete the brief quiz linked below this video. Now to our topic.
Good afternoon, everyone. My name is Michael Obdinski from the Sansin Corporation. I'm the Senior Business Development Manager for North America. And today's presentation is titled Extending the Life of Wood Buildings Through Design, Coding, and Maintenance Planning. So a little bit about Sansin. Sansin pioneered waterborne technology using low VOC formulas and penetrating formulas over 30 years ago. We offer a full line of wood treatments and finishes that beautify and protect mass timber from UV, water, and biological and physical degradation. We offer a program for architects, engineers, and mass timber suppliers called Sansin Iris. And this program assists in selecting the most appropriate coating system for a project and considering the project's needs. So a little bit about today's course. Building with wood, especially mass timber, is gaining tremendous popularity. I'm sure you'll agree. And the architectural community is quickly embracing wood for its sustainable alternative to traditional steel and concrete. And as wood's application and use broadens, its performance must be better understood and steps taken to help protect it. So today's focus will surround the impact of design, performance of wood, the finishes and treatments, the options, and sustainable maintenance. So more specifically, today we'll look at the design decisions that impact the performance of wood. For example, what causes wood to deteriorate and how to manage end grain successfully. Considering coatings options and their impact on maintenance and performance, for example, water-based versus oil-based finishes, and helping the building owner understand maintenance and plan proactively. So let's start with the characteristics that wood offers as a building material. I think you'll agree that wood is the most sustainable building material available to us from Mother Nature, and its inherent characteristics make it strong and flexible. So of course, wood is very strong, especially in compression parallel to the grain. So for example, an air dry piece of Douglas fir 1 by 3 inches can support 4,900 pounds, which is basically the weight of a family car. And also, interestingly, wood can be bent with the right combination of force, heat, and water. For example, in that image you see there, that's the Chicago Zoo. Some interesting glulam pieces. And when mass timber is exposed to fire, which a lot of people don't really understand its effect on wood, the outer layer burns and creates a protective charring layer. And this is the natural protection against fire, or wood's natural protection against fire. So that char layer acts as insulation, and it delays the heating of the wood below it, called the cold layer. And mass timber's high density means that there's no empty space that air and fire can travel in. Most wood has an inherent fire rating of Class B or Class C. And this is why wood construction members maintain their strength during fires, which cause failure of steel members designed to carry the same loads. We're going to get a little bit more about that image further into the presentation. So let's look at the 3 main factors that impact wood. We're going to talk about physical and chemical factors, biological attack, and weathering. So as shown previously, large timbers, they're difficult to ignite on fire. And we all know that you can't start a fire with logs. You need kindling. So in this case, the metal roof structure quickly collapsed after the fire started. This is actually dating back to 1931 in Chicago. And after hours of burning, the 12 by 6 beam actually turned black, reduced in shape and size, and was actually still able to support the collapsed steel girders above it. You can also see the nails that are still in that wood as well. Another example of physical and chemical degradation is iron staining. Here you can see the staining from fasteners, and to avoid this, you'd simply utilize stainless steel or coated nails. Here we have A typical example of mold and mildew due to heightened moisture and the presence of fungal bodies. So you might see this on the backside of your home on the deck. And this shows the importance of good design and why you want to keep wood dry, especially at the end grain and at the connection points. So to note the end grain failure on the railing and the fungal growth on the bridge beams. Here you can see the testing methodology that's used for wood for moisture absorption. This is an ASTM test 4446 using a hydrometer. So when wood is left untreated or uncoated, weathering effects run deeper than just the gray surface. Weathering from the lamination of fiber, the cracking and the checking to blackening and mildew growth can occur. And proper treatment and coating can protect the wood indefinitely in some cases. So to further highlight the effect of weathering, here we see boards that underwent 2,000 hours of QUV testing in a weathering machine. And so 2,000 hours equals about 4 hours or 4 years in Florida. This test exposes wood to extreme UV light, moisture, and heat. And we use this at Sansin to test coatings, especially on various types of wood, Douglas fir or cedar. On the right-hand side of that example, the control sample was treated using, was treated, and the other side was bare wood on the left. And note the difference in the graying, the cupping, and the checking after the accelerated exposure test. So when wood is subjected to UV over weeks, the surface fibers start to change color, they erode, and they even weaken, and that's due to the lignin deterioration. The surface becomes slightly fuzzy at a microscopic level, and this loss, this loses adherence for the coating that would be applied to the surface of the wood. So coating wood with a good quality coating saves the substrate. The color choice can have a significant impact on the UV protection. But as you'll see later, we can achieve a natural look using sophisticated coating systems and protect the wood. So let's turn to design and how that plays a role in extending the life of wood substrate. So lack of overhang systems, exposing wood siding to frequent and direct contact of water flow from precipitation. This can reduce the coating's performance. So wood remains wet and absorbs excessive moisture to the point of degradation, and this causes swelling, rot, and biological growth. An overhang system offers an opportunity to reduce direct and frequent water contact with siding surfaces. And to prevent frequent contact with water at the ground level, other building materials such as concrete, stone can be considered. Ultimately, you want to avoid situations where wood is at the ground contact or on the ground level near a patio or floor, for example. And a simple cap can extend the life of substrate and increase the time between maintenance intervals. So coatings have changed over the years. We went from traditional oils to water-based systems, and now finally we've advanced to waterborne formulas. So traditionally, water-based systems were fast drying. They offered low VOCs and pretty good UV performance. Oil-based systems were known for their deep penetrating benefits and their beauty. Now, we advocate waterborne formula because it offers the best properties of both water-based and oil-based systems. With waterborne, water carries a modified oil deep into the wood, so you get the flow, the beauty, and the clarity of an oil with a strong environmental profile, easy cleanup and maintenance, and faster drying that are all important UV stability. And these are all benefits tied to waterborne technology. So waterborne technology is designed to penetrate wood when wet, but when dry, it repels water and protects from UV. And the best part is it doesn't trap moisture and it stays breathable, which means that the coating won't crack, chip, and peel. So waterborne coatings have the ability to protect wood from moisture, UV, and bioattack, plus maintain a beautiful looking surface. These are hallmarks of waterborne technology. So let's consider maintenance, and specifically preventative maintenance. So there are three factors that impact maintenance frequency. We've already discussed the design and how that impacts the performance of the coating. So let's move on to the workmanship and the coating system itself. So there's 4 main factors to consider when working with coatings and treatments. A successful outcome is dependent on proper preparation, surface preparation, the application, and the dosage. So let's look at these a little bit closer. So sanding is key to realizing the full potential of the coating. You mechanically sand the wood to open up the pores and allow the stain to dive into the wood. This can be done by either blasting or sanding. Here we can see an unsanded side of cedar and the mill glaze, which is remaining on the surface on the left-hand side, which wasn't sanded, it was just left naturally. And when you simply drop a droplet of water on the surface, you can see how the mill glaze surface or the unsanded side, it just has water tension and it bubbles on the surface, whereas the sanded side allows for absorption, almost instant absorption, which means the coating will sit on top of the wood and it could actually result in premature coating failure. So we support following the manufacturer's specifications for temperature and humidity during application. Specifically, those are some key points. These will impact the outcome and the success of the coating. There's many ways, of course, to apply wood coatings, from brush, a traditional brush, or to flooding the coating on with a spring system, and ultimately also using pre-coat machines in a factory setting. So we encourage machine application in the factory setting when possible, since application occurs in a controlled environment and quality control can be managed. So proper dosage, specifically on the first coat, can greatly improve the coating's performance, and reference the product data sheet on wet mill thickness, which will ensure enough product was used to maximize performance. Another way to measure proper dosage would be to weigh the substrate before and after application. So balancing beauty, durability, and the ease of maintenance are the main considerations here. And through our Sansin Iris program, we work with you to consider the pigment loading to improve the UV performance. And we talk about how to utilize stains and finishes to create a unique look. We also consider non-film or film building options along with the preferred sheen to develop the coating schedule. And there may be many possible outcomes, but we always keep maintenance or ease of maintenance in mind at all times. So for example, from Douglas fir to Alaskan yellow cedar to Akoya, there are various options for mass timber finishes that balance beauty, protection, and performance. So in summary, when considering maintenance, plan for annual inspection, look for signs of wear or loss of water repellency, and preventative maintenance is less costly than full restoration. And I'd like to share at this point some noteworthy projects with you that we've been involved with in the last several years. So here we have the Toronto Montessori School. These are Douglas fir timbers that were supplied by Timber Systems out of Markham, Ontario. And Sansin's 2-coat system, KP12 UVW with a precision coat SDF top coat were applied. The top coat was custom tinted to create this natural look. And as you can see, we were able to maintain the beauty and the clarity of the wood. This project in Amsterdam highlights the use of a weathering treatment called Wood Force. This allows the wood to grade naturally and mitigates damage from moisture. In this image here, you can see this picture was actually taken some 5 or 6 years after the application. The Videotron Stadium in Quebec City, this incorporates 92 glulam needles supplied by Nordique. And the KP12 was factory applied, and a final coat of Sansin's Purity Clear helped create a brilliant finish. This one's near and dear to my heart in my hometown, London, Ontario. It's our local ski club. So here we see 2 parts of the building. On the right-hand side is the old part of the ski chalet. On the left is the new chalet. And we applied the SDF Autumn Gold on the right-hand side. And on the left-hand side, a fire retardant was required for the softening. So we were able to use the fire retardant coating tinted to a similar color as the SDF on the right-hand side to blend the look together and also achieve the building code specifications for the project. This bridge in Banff National Park utilizes KP12 and SDF top coat with the substrate supplied by StructureCraft. And it's held up extremely well. And what's really noteworthy here is that this bridge is actually flooded during certain parts of the season. It's literally underwater. This is Hayward Stadium in Oregon. It consists of almost 500 glulam pieces. These are supplied by Western Archer of Canada and designed by SRG Partnership of Portland. And this project used KP12 UVW and then 2 coats of our film-forming, long-lasting ENS finish. That first coat of ENS was actually applied in the factory, and they field applied the final coat of the ENS system on site, which had a half-tint load of golden wheat. This project was designed by Luber Trubka. This is a First Nation project located in North Vancouver, actually, so near to some of you that are joining us today. And by pairing mass timber elements such as glulam columns, beams, and stairs, and nail laminated timber panels with traditional materials like Douglas fir for the siding and red cedar columns and the beams, the building expresses strength and resilience coupled with a sense of well-being, reflecting both local history and the native landscape. So inside and out, Sansin was featured on this stunning building with products ranging from our SDF product to our foundation and ENS Optimum Clear for a high luster film build finish. And then for the interior, our gymnasium grade floor finish for high durability. And lastly, this is a 150,000 square foot project that was designed by Michael Green Architecture to be one of the largest zero carbon, zero energy buildings in North America. And Catalyst anchors a new South Landing neighborhood in Spokane, Washington, which is a model for sustainable development and to bring out the character of the wood and add to the stability requirements of the project. Sansin products were used throughout. And inside, Sansin KP12 UVW and SDF top coat were custom tinted and used on the lighter areas, while Purity Interior Stain, tinted to a midnight color, and Purity Interior Glacier, which is a non-yellow and clear coat, created the bolder accents. And the exterior CLT soffits, as well as the Alaskan yellow cedar cladding and columns, were coated with KP12 UVW and our SDF top coat system. So those were just a few projects that we've been involved with. And that concludes our formal presentation. And I'd like to open up the floor to some questions and maybe talk a little bit more about our Sansin Iris program. So thank you.